Good morning, everybody. Yeah? It's a great pleasure for me to present to you a very small study. It's a pilot study, and this is something that should be taken into account about all of results. But a little step about infrared thermography and circadian rhythms. Why? Then, in the introduction, the topic circadian rhythm is something that from our general topic as physical activity and sport, and also in other topics, is very current. It's a very active, dynamic topic, but it's mainly treated or analyzed through color temperature. And my question is, why not about with thermography? Yeah, there's something that someone that is less known, for example, Professor Ring, he's just started, in the topic, or another authors like Van der Hebel have already proposed to do is analyze circadian rhythm not only with core temperatures but also with thermography. And why is that so important for us? Like as I have already said, we come from physical activities and sector, the sport sector, and normally we have in our methodology we use mainly thermography to detect, to evaluate the risk of injuries by comparing, and in one single unit of activity we can evaluate one single photography in a bilateral way. It's to say a quadriceps, red part of the body with the opposite, and as well with a proportion concept. Is this way, this part compared with another muscles or body areas. But there is also another kind of way of analysis. This is a longitudinal activity. That is to say, one single subject through the time, or even through a group. In that case, it would be the case, for example, of a football or a basket, a team, sport team. Then the pilot study was very simple. Just 2 young men, physically active. We made a follow up just from 13 hours. The rest of the time the faculty was closed and we couldn't make the whole follow up. But we tried to Spain. We have to save money. And then we studied. The protocol was this that we described in a pattern, but it's highly close from Glamorgan, and it was a controlled room with controlled parameters in between. The standardization. We use a camera T335 is a normal one, and the temperatures, the software, we analyze the data with a software called the thermotracker. Then, as Ring and Ammer proposed in one paper, we used calibration it as a temperature reference, and we will explain why after. And the regions, through the software, we are able to take the temperatures, averages, and so on from I think that's 78 body areas. It's not the same thing as Glamorgan protocol, and we decided to take from each image one region of interest, who was the inclusion factor was main body areas and without direct influence from external factors. And in that way, we take pectoralis, dorsal, rectus femoris, and calf. And that's just one impression of how thermotrachea works. It analyzed, takes the photo, and how Ricardo explained, it makes an automatic recognitions of body areas, and from each one, for example, here is represented only rectus femoris. It takes here average, maximum, minimal temperature, and standard deviation. There's a great advantage here. Okay, and then the results. I remember it is just a pilot study, but during the evolution of both subjects was very surprising, and this is a relationship between these results and those that has already shown Ricardo, because the average was very, very low, the symmetries, and through the time, all the time it was very, very low, and that is me. The way we analyze one single photograph just by comparing bilaterally is highly recommendable. We can recommend that as a way to just detect abnormalities in body areas. But the fact is, the evolution of temperatures, in that case not asymmetries, but the temperatures from, in that case, upper body areas, lower body areas, and general, well, a little bit strange. Why? It's normal, a normal one, but by analyzing the evolution of, in that case, for example, I don't know, pectoral or something like that, we see it like, for example, from 8 o'clock in the morning to 9 o'clock, it came hotter, then colder, then hotter, then colder, then hotter, then colder. What is that? It's a joke. We didn't understand the mechanism of these big changes. And in that graph chart is also represented the results of the background reference, the temperature reference. And then we didn't understand so good why the temperature of the room is the black line was relatively constant, and however the evolution of this temperature between areas was so strange and always changing from hotter to colder. When we stayed in the same room doing nothing excepting going to eat, going 2 o'clock, we go to the cafeteria, but the rest of the time we stayed in the same room, but, about the same conditions. Then we decided that maybe the good way to analyze that was to avoid the possible calibration error that is mentioned before, correcting the register temperature using a temperature reference. I tried to explain. I think that's very complicated, but the fact is that we eliminate the difference between room temperature and between reference, temperature reference, the black body that we place in the background. Okay? And then the temperatures were corrected, and it made some sense, at least more sense than in the last results. You can see here after the evolution of temperatures and the corrected one. This is not a big difference. Yeah? The regressions between each body area and, in that case, the background temperature, this reference temperature, were high but not significant. Yeah, except in the case of cough, and it could be explained because, and I saw that is difficult, because we were in the same room, but just going up, standing up, and the only muscle group that we used the most between all these body areas was calf, and maybe that's the reason why the reference, the regression, the correlation is not that high. Our discussion is the following. Our results are this one, and in other studies, for example, this one, Edwards, the evolution of core temperature, not body temperature, was a little bit different from low to high and then descending. Our evolution was, but not, the correlation is not that easy to see, because, of course, we are not talking about the same things, core temperature and skin temperature. But we find something that is surprising from work from Professor Ring. There was an analysis from skin temperatures and through the day, from 9 a.m. till 1 p.m. And we saw, I'm sorry, the transparency is not so good, but it fits so good by some examples from the pilot study. Our conclusions about that topic, about that result, is just that the first hand, we should say that asymmetries, the evolution of asymmetries are very low, and then we think that it's a good way to compare and to detect abnormalities just with one image. However, longitudinal evolution is influenced in any case, and we need further investigations, and we consider that temperature reference in the background should be recommended in order to avoid the theoretical, the possible error from cameras. For example, we have to accept that one of our faults was not to take on the cameras with enough time before each photo, each time, and that could be a reason why the calibration of the own camera was not right. Yeah, and the third conclusion is, however, skin temperature evolution could be different from core temperature evolution. Like always, yeah, from a pilot study, the conclusion is, okay, we have already researched something, but we need further studies and further work with more sample and a better methodology in order to establish better conclusion. That is all that I wanted to say. I would like to thank you for your attention, and I'm open to try to ask some questions. Yeah.